Okay, welcome. Still on 2018 Mathematics Paper 1. This is question number 22. And here is the question. So, on the grid provided, this is the grid. Draw the graph of y equals to 4 minus a quarter x squared for values of x ranging from -4 all the way to 4, or x is equals to -4 and also x is less or equal to 4. So for this particular case, we need to have a table of value. So this is what we are going to have. Need to appreciate that this one is our table from -4 all the way to 4. So here we have x and here we have y, -4. So from -4, the next number towards the right is -3. We write it here. And then from -3, we move all the way to -2. From -2, the next is -1. From -1, we move to 0. From 0, we move to 1. From 1, we move to 2. From 2, we move to 3. And lastly, from 3, we move to 4. From 3, we move to 4. So this is along the x-axis. And along the y-axis, we are going to substitute for our values here. That if x is -4, what will be the corresponding value of y? So we use this equation here. That every y is given by 4 minus a quarter x squared. So if it is 4 minus a quarter x squared, if we square -4 here as the value of x, -4. So -4 squared is 16, and a quarter of 16 is 4, and 4 minus 4, the corresponding value of y will be 0. So if we square -3 squared is 9. So if we take 9 over 4 and then we subtract the product from 4, we are going to end up with 1.5. So if x is -3, the value of y is 1.75, positive, like that. If x is -2, so -2 squared is 4, and a quarter of 4 is 1. So 4 minus 1, we are going to have 3. If x is -1, -1 squared is 1, and a quarter of 1 is 1. Is a quarter of 1 is a quarter. And then 4 minus a quarter, we are going to end up with 3.75. We write it here, 3.75. If x is 0, so everything here will be 0, so we end up with y as 4. If x is 1, so these values are going to repeat themselves. We are going to have 3.75 here, and then we are going to end up with 3 here, 1.75, and lastly, we are going to end up with 0. So this is the table of value for the function y is equals to 4 minus a quarter x squared. So we have to draw the graph of this function. So for the graph of this function, this is what we are going to have. Since we have the negative and positive values of x, so we are going to divide this graph of ours into 2 equal parts, that is towards the right and towards the left. So we have this axis here, which is the vertical axis. I refer to it as the y-axis. So, and the horizontal one will be the x-axis. The horizontal axis will be the x-axis. I'm going to have it here. The horizontal axis is always the x. axis. So this is the horizontal axis. I call it the x-axis. So this is the positive side and this is toward the negative side. So we can have 2 and then I have my 4 here. That every division represents a unit along the x-axis. And then this one will be -2 and -4 will be somewhere here. So along the y-axis, I'm going to talk of 0.51, 1.52, 2.53, 3.54, and then 4.5 all the way to 5. Me have it as a scale of 1 unit to represent, or 1 centimeter to represent 0.5 units along the y-axis. So if x is -4, the corresponding value of y is 0. So -4, 0, I'm going to plot it here. And if x is -3, the corresponding value of y is 1.75. So where am I going to have 1.75? If this one is 1, at this point I'm going to have a half, which is 1.5. Then 1.75 will be in between 1.5 all the way to 2, 1.75. So if x is -3, y is it is positive 1.75. So positive 1.75 is going to be somewhere here. We're going to count 5 divisions from this point. 1, 2, 3, 4, 5. So it is going to be somewhere like this. If x is -2, the corresponding value of y is 3. So if x is -2, the corresponding value of y is +3. So we have it here. And if x is -1, the corresponding value of y is 3.75. This is 3.5, so 3.75 is somewhere here in between. And if x is 0, the corresponding value of y, it is at 4. So that is it. And if x is 1, we have 3.75. 3.75 is somewhere. It is going to repeat itself. If x is 2, the corresponding value of y is at 3. If x is 3, the corresponding value of y is at 1.75. So 1.75 is somewhere. And lastly, if x is 4, the corresponding value of y is 0. So because it is a curve, this is how we are going to draw it. So you use a pencil. We are going to use a pencil. And it should be a smooth curve. It should be as smooth as possible. Should be as smooth as possible. So from this point all the way to 4, 0. So we are going to label our curve, and this is a curve of y equals to 4 minus a quarter x squared. So we are done with part A of the question. So that is it. For part B of the question reads, use trapezium rule. Use trapezium rule with 8 strips. Estimate the area bounded by the curve and the x-axis. So the area bounded by the curve and the x-axis. This is the curve and this is the x-axis. So for the 8 strips, we are going to have the first strip. That is it. The second strip will be this one from -3 all the way to -2. The third one will be from -2 all the way to -1, and then from -1 all the way to 0, from 0 all the way to 1 is another strip, from 1 all the way to 2 a strip, from 2 all the way to 3, and lastly from 3 all the way to 4. So these are 8 strips. 1, 2, 3, 4, 5, 6, 7, 8. So for the trapezium rule, the area is given by a formula which states that area under a curve, it is given by a half h to a larger bracket and then y node plus y. And this one is the first and the last plus 2 and then the sum of middle values of y, corresponding values of y. So the height will be this dimension here from one particular point to the next. So from -4 to -3 we have a difference of 1 unit. From -3 to -2 a difference of 1 unit. From -2 to -1 a difference of 1 unit. So the height will be equivalent to 1. The height is 1. And our first value of y is at 0. This point here, it is at 0. And our last value of y is also at 0. So y node we have 0. Yn we also have 0. So the sum of the middles are these ones: 1.753, 3.754, 3.753, 1.75. So the middles will be 1.75 plus 3 plus 3.75 plus 4 plus 3.75 plus 3 plus 1.75. So if we add all the values for the middles, we are going to end up with 21. We are going to end up with 21, this sum. So the sum here is 21. So for the area, it will be a half times h, which is 1 unit, into 0 plus 0 is 0, and then plus 2 into 21, like this. So 21 times 2 is 42. So this one is a half times 1 times 42. By 2, 1 by 2, 21. So it will be 21 square units. 21 square units. This becomes the area bounded by the curve and the x-axis by the trapezium rule. So for part C, we are to find the area, or find the area estimated in part B above by integration. So by integration, we are going to integrate our curve. We are going to integrate our curve, and this is the curve from -4 all the way to +4. We are going to integrate the curve from -4 all the way to 4. So the function of the curve was 4 minus a quarter x squared, like this. Remember, it is from -4 all the way to +4. With respect to x, of course, with respect to x. So for that case, the integration part will be, the integration part is going to be 4x minus 1 over 12x power 3 and then plus c. So how do we integrate? This one was, if we introduce x here, it is going to be x power 0. If we introduce x, then we are going to raise it to power 0, because initially we had no x, and any number raised to power 0 is the same as 1. So if it is x power 0, 4x power 0, we add 1 to this power, and then over 0 plus 1 minus a quarter. X was squared, we add 1 to the power over 2 plus 1, which is 3, and then plus c. Then as a result, we are going to introduce the limits, and the lower limit is -4, whereas the upper limit is +4. So let me utilize this space here for continuation of part C. So if we talk of 0 plus 1, we are going to have 1, and 0 plus 1 down we go. So it is just going to be 4x. A quarter divided by 3 is 1 over 12. And then it will be x power 3 plus constant c. So this is what we are going to have. That is what we are going to have. X power 3 plus c plus c. So if we have -4 and 4 here, how do we get the area now? So for you to get the area, we introduce this 4 here. It will be 4 into 4 minus 1 over 12 into 4 power 3 plus c. And then we are going to subtract 4 into -4 for the lower limit now, minus 1 over 12 into -4 power 3 plus c. So for the first case, we are going to end up with 10. For the first bracket, we are going to end up with 10 and 2/3 plus c. And then for the second bracket, if we substitute, you are going to end up with negative 10. It is going to be negative 10 and 2/3 plus C also. So this brings us to 10 and 2/3 plus C. Minus and minus will be plus. 10 and 2/3 minus. So this C and this C will cancel. This will result into a final answer of 64/3. So 10 and 2/3 plus 10 and 2/3, this becomes 64/3, which is the same as 21 and a third square units. So the answer by integration becomes 21 and a third unit square. So this one is it by integration. For the last part, we have to calculate the percentage error in estimating the area using the trapezium rule. So for the percentage error here, we need to get the error. And the error is usually the actual area minus the estimated area by trapezium rule. So the actual area is that by integration, which is 21 and a third. And the estimated area, we've calculated it as 21. That is the area by trapezium rule. This is the estimated area, 21 units. So if we subtract, we are going to end up with an error of a third. So it is a third, the error, divided by the actual area. And the actual area here is 21 and a third. And then we multiply this one by 100%. We multiply by 100%. So that brings us to an area which is, or a percent, which is equal to, remember this one is a third, divided by 64/3 times 100%, which will be equal to a third times 3/64 and then times 100. So by 3 by 3, 1 by 64 by 64, 1.5625%. So this becomes the error. That becomes the error.